Here it's until 10 o'clock.
I know, it's more difficult.
Yeah, it's
You won't be here though. You
Yeah.
won't be here.
Yeah, no, we will be here for 2 days.
Oh, 2 days. You'd be strong. Yeah.
Like 1 weekend.
Yeah, you'll survive, don't worry.
Actually, no, when you go to Sudan, you will miss it because the weather.
Yeah. It'll be
You'll
too
very
it'll be too hot for
hungry.
you.
Yeah, you'll be very hungry. Really.
Yeah.
You'd be very what?
Hungry.
Where?
Yeah.
Oh yes.
Yeah. Until then, you won't be thirsty, but you will be very hungry.
Yeah, yeah. You won't be thirsty because it's not hot.
Yeah.
I'd rather be hungry than thirsty.
Yeah. No.
I kind of agree with you. I'd rather be hungry than thirsty. I don't like being thirsty. I'd rather be hungry. Because you can kind of forget about being hungry if you're busy doing something. It's more difficult to forget that you're thirsty because you can feel it more.
I'm good at forgetting being hungry.
Yes, but not being thirsty.
No.
Yeah. Okay. Next lesson is very easy, which is maybe
You
good.
won't do any one from.
What I'll do is, if you want, in the next class, I can do them at the start. Then you mean from the last one?
Yeah, but we will forget it.
Not if you try at home.
We do. Won't help.
You'd be surprised. It
Will
might.
it? No. We
Okay.
won't.
Okay.
Yeah.
There we go.
Won't help. Really.
No, I'll let you try at home. Then I'll do it next time. It might help. I know you don't believe me, but it might.
No, I believe you.
No, you don't. But that's okay. All right. Next now. Okay. Vector base, if you can write that down. Okay, so we've talked about position vector, but now we're going to talk about two special vectors called I and J. And this is OI and this is OJ. So we have I and we have J. What's special about these vectors is that they're perpendicular and also their magnitude, their length is 1 unit. So they're at 90 degrees and they're 1 unit long. Do you understand so far? What's really, really nice about this is that no matter what vector we might have, like here, let me just draw one here. Let's call this vector x. We can always write that vector using i's and j's. I and j. So for example, in this picture, for example, x looks like it's, 3 i's plus, I don't know, we'll say 2 j's or something like that. Do you get it? Like, it's like the I and the j, you can write every vector in terms of I and j. So that's why we call it a base. It makes a base for all the vectors. Yeah. So maybe this reminds you a little bit of physics when we're talking about horizontal and vertical for the projectiles, the components. Do you remember? Yeah. So we can have some rules here. So before I do the rules, maybe you want to write this down then. This is a basic example here. So, yeah. Yeah. Those pancakes were good. I could have done with 2 more of them. Okay. Now let's have a look at some rules. So, the first rule, I suppose, well, not really a rule, but just what I'll say is, we'll write the vector as xi plus yj. Now, because these are special vectors that are 1 unit long, we can write them using this symbol instead, a little hat. This is to remind us that they're 1 unit special vectors. We can put this little hat on them. I don't know, have you seen this hat before? You have? No? Anyways, it just reminds us that they're unit vectors. Okay. So the good news is, if you want to multiply, so this is like the first rule, if you want to multiply this vector by a scalar, then you just have to multiply each of the components by the scalar as well. Make sense? Likewise, if you have 2 vectors you want to add together, let's say or1 plus or2, then you would just add the i's and the j's like usual. x1 plus x2i plus y1 plus y2j then. Yeah. Okay. Now let's have a look at another rule. So if I have or equals xi plus yj, and I try to draw that, here's I, here's j, there's O, there's or. How long is it from here to here? Very good. And here to here? Right. So if you wanted the magnitude of or, what rule could you use? What's it called? The magnitude, the length. If I want to know this length here, what rule could I use to get that? Yeah. And then how could I get this angle here? Yeah, tan inverse y over x. Where have you seen these 2 rules before? You've seen them somewhere before? Yep, yep. Okay, so still I want you to write them down, but these are the 2 for this class.
You should stop recording this one.
I've done that before.
How was it?
I think it was okay because I was in university, so I wasn't as busy as I am now. I think it'll be more difficult now to stop the coffee because I have longer days. You know what it's like in university, you know, you just wake up, go to class, go home, play some video games. Easy life.
Oh, fun. Oh.
Hang out with friends, go to Starbucks.
It seems like hang out with friends. Go to Starbucks. Actually don't.
I think there's some time for friends in Starbucks.
And holidays.
You didn't even go out in this place. You just played football with friends, right? Like, yes, right?
What were you studying? All your subjects?
Huh?
Why were you studying so much?
Why what?
What were you studying?
In Prego,
Yeah,
I studied all the
all the subjects. So now you're an expert.
science.
How is your maths report going actually? You probably haven't started since you're doing the physics, or have you? I don't know. Yeah, the maths, yeah. And what about the physics lab report? How did it go? It's okay? Yeah.
How was my feedback like generally
For what?
for the trial that I sent you? Like,
I gave you feedback.
yeah, it was good.
Oh yeah, I wrote the things in it I needed you to change.
That's it.
No, there's always room to improve. It's never going to be perfect. Yeah. Not even I would get 100%. There's always something you can do better. Yeah. Okay. Now, next, this here, when you write, well, you know what this one is. This is the real numbers. When you write this, it's 2 dimensions. So this is like I, this is like I and J. So this is 3 dimensions. And we use I, J, K for 3 dimensions. Amazingly, the rule is still the same, except it just has an extra letter.
But how about that?
That we'll talk about later. That's not the same. We'll talk about that later. But for the length, it's the same. Okay. Now, what else the other rules do you need? Oh, yes. And so you could say or is a position vector. Let's say like 2i plus 3j plus 4k. So if you were to draw that, that would be 2 units on the I, 3 units on the j, 4 units on the k. Yeah. It's kind of a pain to write IJK all the time. So what a lot of books do is they just write it like this, 2, 3, 4. So in other words, if you have xi plus yj plus zk, you can easily just write that as xyz like this. It means the same thing. In the exam, they usually, I would say 90% of the time use this, although 10% of the time they might write it like this. So you need to know that. If you can write that down, please. When is Ramadan this year? What date?
In May, 28th.
27, 28th of May?
Yeah.
Oh yeah.
You will finish at 28th, yeah.
Something like that, yeah. $30 days. A calendar month.
Mm-hmm.
Yeah.
Full moon orbit.
Yeah, one full moon orbit, yeah.
What?
Oh, come on. You should know this.
Yeah, I know, but what is the full moon orbit? Like, what will happen after?
The moon goes around once.
Ah, you mean 28?
Yeah.
Ah.
Isn't this like what you use in the Middle East for months, yeah?
I don't even know which year it is anymore. It's been so long.
Since you checked?
Yeah.
But they use it in the Saudi Arabia.
Yeah, but I don't. I'm at home.
Yeah, what is it? Is it like 1200 or something? I don't even know.
1430.
14 something, yeah.
38, 30. I don't really.
Yeah, something like that.
We only celebrate when it become New Year in Sudan. We don't care what it is.
Well, yeah.
We only celebrate for it's New Year, eh?
Yeah. And New Year will be different for you than for me, right?
Yeah.
Yeah.
Yeah. The when does your calendar start? It's not January. You know, like the Chinese one is usually, the Chinese New Year is usually like in March.
Change.
So what was it last time then? Yeah.
But
Well, was it summer or winter or spring?
It wasn't too long ago, I'll say that. Probably right before I came here, so
Maybe summer?
maybe.
Yeah, okay. But like you said, that's only you celebrate once a year, and then you forget what year it is.
Yeah.
Yeah, it's funny because I kind of forget that other countries would use different years because I only think about Europe and America, but I forget that like in Saudi Arabia, their dates on their newspapers would say 1438 or something like that. And I suppose, I don't know, now I have to ask the Chinese students if they must use their Chinese calendar on their newspapers over there, which is different as well, you know. I think it's probably a big number because China's quite old, you know, a few thousand or something. Okay, let's have a look at some questions here. Like I said, they're very easy, so I'll do one of each. So the first one, draw -8 plus 6. Okay, that's very easy. I'll just do a very quick axis to help. If I make this I and I make this J and this is O, then -8I would be like way out here, and then 6J would be way up here. So very, very roughly, you know, some vector like this. I don't even think you need to write that down, do you?
no.
No. But let's look at the next one. Simplify this. Okay, so maybe you just want to write this one down and I'll do it here. Can you? Yeah. I'll do it if you can write it down.
You know the bracket thing where you put the numbers on top of each other. Can I do it with the I and J, or does it have to be 3 of them?
Yeah, if you do with I and J, then the last one's 0. So we can do it like that if you want, actually, just to make it a bit different. So this is 3, and this is 8 minus 4 and 0. And this one is plus 3, and then it's 4I, 5J, and no K's. So you should multiply in the 3 and the 4 first. You know, like open the brackets.
Yeah.
24 minus 12, 0. 12, 15, 0. 36, 3, 0. 36I plus 3J plus 0K, if you like. Very easy again. Do you need to write that one down? No? Okay. Now, the next one. Again, because you've done physics, it's so easy. Let's say this vector, for example, is 5 units long, and this one is 30 degrees, and I want to know the I part and the J part. Well, yeah, it would be 5 cos 30 I plus 5 sine 30 J. Again, like I said, very easy stuff here. Okay, now time to talk about, but I need to get a picture up here. So, Musharif, you were asking me earlier, what about the angle? You were asking me, yeah. So, it's a bit different in 3 dimensions, because in 2 dimensions, you really only have one angle. But it's more complicated in 3 dimensions because, how can I try and show, like here, you have an angle with the ground as normal, but then if you look at it from the top, you also have an angle with the wall. I'm going to try and find a nice picture to show you this. Angles of vectors in 3 dimensions.
The picture that will be showing is the picture for the pancake.
For the what?
If you go back again, this this picture one.
This picture?
Yeah, just the picture like that, Santa Claus.
I don't think this is Santa Claus. It's a
No,
little bit.
for the pancake.
Is it?
It's for, I don't know this person.
Abdul Fattah, he is Muslim.
No, I figured that part out, but I don't know. Pakistani philanthropist and humanist. He runs hospitals. Okay.
Okay.
Did you know him before?
No,
Okay.
Fattah.
Right. Let's have a look at the pictures here. I'll get it.
No, no. Yeah? Yes.
Maybe.
Mir might know. Maybe. Okay. I want a nice picture here. Here we go. Okay, can you see this picture here?
Mm-hmm.
It's okay. No, it's not great. But there's two angles.
Yeah.
One that's on the ground and one that's off the ground. Yes, the wiki page. Maybe if I can just go to the wiki page, usually it's good. Yeah. Or Euler angles, actually, if that one doesn't work. It's hard for me to draw 3 dimensions, as you can imagine. Yeah, it's the same picture, that's okay. So
We can see it, like the triangle is outside.
yeah, you can see, like, here's the point in 3 dimensions, and there's one angle on the ground, and then one angle with the z-axis here. This one is called phi, and this one's called theta. So, to calculate them, I'll show you the formulas here.
It's a wall.
Yeah,
If you want.
it's in the corner of a wall. Yeah. Here we go. So, theta is cos inverse z over r, which I'll just translate that. So theta is cos inverse z over the magnitude of r. So if you have your vector here, the theta is cos inverse the z part over the magnitude of the vector.
And the magnitude is
Square root x squared plus y squared plus z squared. So if you want to write it out more fully, this is the formula here for theta. And then, it's hard for me to draw, but then there's an angle on the ground here called phi, and phi is tan inverse y over x.
Two dimensions.
It's like the 2-dimensional version on the ground.
Mm-hmm.
So, this is what you were asking me earlier. The situation is different for angles. You have 2 angles instead of 1. So these are the 2 formulas, if you would like to write them down, please. I don't know, do you want to try and draw the nice picture too, or?
no. I'm very bad at
What
drawing.
is that here? Like,
Sorry, I didn't write that in. IJK, XYZ.
oh.
I'll put it in here. This is like the I, this is like the J, and this is like the K here. So, in 3 dimensions, we call the ground I and J, and the height is the K. So, K is a height.
So it's cos inverse K over the magnitude.
The K component over the magnitude,
the
yeah.
Y,
The height, yeah.
the height.
Yeah.
Like the Y in the 2 dimension.
Yeah, I know it's strange. It's almost like you take the 2 dimension and you turn it on the ground, and then make the new one the height.
And the J is X.
Yeah, I don't know. When I first learned this in university, I found it strange because to me, and you're probably thinking this as well, if this is I and this is J, then it seems like this one should be K.
Yeah.
Mm-hmm.
But it's almost like you flip it down to the ground and then make the height K. There is a reason for this, which I don't remember what the reason is, but it's actually a bit better to draw it like this. I know it doesn't seem like it right now, but I think there is a good reason for it.
Because we don't use it like this. Like we use X for I, Y for.
Yeah, you can write in X, Y, and Z, but I'm trying to stick to what's used in the exam, which is I, J, and K.
No, I mean we don't flip it.
Are you sure?
Yeah.
Well, that's right, because I think the reason for this is something to do if it's a left or right system, and in Sudan
Right.
it's right system, so maybe it's the other way around. You know, I draw my right angles like this, right angles. Maybe you draw them like this in Sudan?
Yes.
Would you call them left angles?
No.
So call them right angles? If you
No.
translate?
We
No, we
don't
draw
even
the right angle like this.
Oh, you keep it like
no,
this?
No.
Really?
No. Yeah.
It might depend on the country. You would draw it like this in Sudan.
Yeah.
But what do you call this angle if you translate it? Do you call it a left angle?
No, and it's not right.
It's a different word. It doesn't use the word left or right. Okay. Yeah.
Stand angle. So, the other one,
Mm-hmm.
standing angle.
Standing angle?
Like stand angle.
Oh, okay. Like standing up.
A 90 degree, yeah. So
Yeah. Like an upright angle.
Yeah.
Okay. Did you get these two angle formulas? Yeah. So, if you've got your calculator, why don't we practice for the first one here? So let's calculate the theta.
The two.
Yeah, theta and then phi. So let's do the theta for this one. If you take out your calculator.
It will be done in the
Tan inverse minus 54 over square root. No, not tan inverse, it's cos inverse. Cos inverse minus 54 over square root 95 squared plus 38 squared plus 54 squared.
This is the phi. No,
This is the theta.
the theta. Ah.
You know your Greek letters?
Yeah.
Do you know them all?
Of course.
Don't worry. When you go to university, you'll have to learn them.
No, don't have to learn all of them.
What are you going to study next year?
Mechanics.
You'll learn all of them.
Why?
Because all of them get used.
Really?
Oh yeah, that's how I know them.
Okay.
Yeah.
It's language class.
No, you'll just remember the names.
It's 90.
Roughly 90. Okay. And then what about tan inverse y over x? So that's tan inverse 38 over 95. Okay. So what we'll do now is, if you just do one part from each, and then we'll finish. They're very short, so like just do, B.
Can you draw the last one?
Draw?
Yeah.
I don't know if I can. The numbers are too big.
Then yeah. Okay. If you can, then it's okay. But
No, I'll try.
then it's
No,
more
I don't
complicated.
want to disappoint you. This one is I. This one is J. This one is K. I'll put it in a different colour. I, J, K. So minus 95I will be way back here. And then minus 38J will be way back here, but not as much, so like something like that. And then minus 54, yeah, that would be like down here. So it's like the vector points away from you. See, but it's because it's in two dimensions, it's hard for you to see the depth. You don't get a feeling that this arrow is pointing away. So this is why they won't ever, I don't think they'll ever ask you to draw this, because it's too difficult. Now they might ask you to draw this, 2 dimensions. I don't think 3 dimensions. Just try one from each and then you can go. Like B, 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 B and B. And I just want a quick picture, 5 minus 12, done. Sudanese music? So not Taylor Swift then?
No. Oh.
Okay, you probably should have the first one nearly done by now. I just wanted a quick draw on. Have you got something there yet?
Okay, so how do I draw the line?
What do you mean?
Like, okay, this is my I, this is my J.
Yeah, so you want 5 units on the I and negative 12 on the J.
That's the point. Do I draw a line between them?
No, it's like coordinate geometry. Come out 5 and go down 12 and then draw to that point. So it's like here, what is it, 5I? So you go out 5 units and then down minus 12 and draw it there. No, that's what Ehab was asking me. It's not like that. It's, you go out 5, you go down 12, put a point here, and it's from the O, it's the position vector. Yeah, that's it. You got it? Okay. Alright, try the B one here in number 2.
7 multiplied by how much?
7 multiplied 9 is 63. But it's not, oh it is, yeah. Do you not learn this in Sudan?
No, we don't.
You do learn it? Okay.
Yeah.
Minus 30.I.
Yeah?
Minus 56.
What?
You're off a little bit on the J. What did you say?
56.
I got 70.
I got 70 also.
Sign mistake you had? Maybe you missed up with a... It's going to be minus 7, minus 63 for the J.
Minus 7 minus?
Yeah, because there's a minus 1 here.
Oh, yeah, okay. Oh.
We finished by now.
There's still 5 minutes left.
Yeah.
I gave you a longer break today because I needed my pancakes.
It wasn't a break. We were...
Were you working really hard?
Yeah. Very hard.
So you want to finish now?
Yeah.
What class have you got? 11.
Can,
Oh, I better give you a break, so.
yeah.
Yes, okay.
It's
We're-
very, like...
It's tiring, I know.
Yeah.
Life is difficult, yes, I know. So much to do, so little time.
Chemistry is the most tiring right
Yeah.
now.
Why? What are you covering?
We're gonna, I think, all the time.
Okay, well you can only do one per class, so what topic are you on now?
Organic.
Organic chemistry.
Reactions and all that stuff.
Is organic chemistry a big part of the course?
Yes. I
Yeah.
think it's 100 page or more.
Oh.
And it's all, you have to remember all of it.
Yeah, all the vocabulary.
Yeah.
Yes. The what's it called? Nomenclature.
Vocabulary, all the formula, or the names, or everything. Every slide.
Dihydroxide. Have you done that one?
Stuff, yeah, that stuff.
What's dihydroxide? Think about it, dihydroxide.
What is hydroxide? Two of
Two, yeah?
It's water.
Yes. Very good.
Water is hydroxide.
Dihydroxide.
H. So di, like H2O.
Yeah. That's the only one I know, by the way.
You want to do
Yeah, you can take that out. We have class later, so I'll take